Hello viewers, welcome back to class. I'm super excited to welcome you guys back to Master Builders Online Academy. So if you are new in this channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more exciting videos. This is very important for you. And also don't forget that anytime you are set to watch and to learn new concepts from our platform, do not entertain any form of distraction. This is for your own good. And ensure you do not skip any part of this video. This will help you very well. Otherwise, you may skip important aspects that will help you gain mastery over this aspect of this class. So guys, don't skip any part of this video. And if at the end of watching this video, you still have not understand some major concepts, guys, you have the opportunity to replay the video over and over again until it sinks into your mental capacity. And if at the end of replaying the video over and over again, guys, you still have questions to ask, don't hesitate. Slide to the comment section and make your questions known to us. We are good at asking questions, then we will answer your questions to your satisfaction. Don't forget to like this video, share this video, and make your necessary comments. So if this is taken, let's get to the business of the day. Now, on the board, we are still examining the design of reinforced concrete beam. And now we have problem 3 before us. As you know, we are problem solvers. So therefore, we are asked to determine the ultimate moment of resistance of the reinforced concrete beam section shown below. Given that the characteristic strength of the materials are 30 for concrete and 460 for steel. Now, this is the sketch or the diagram shown below with the respective dimension and the area of reinforcement. So guys, this question is actually a reverse of question number 1 and question number 2, or problem 1 and problem 2. In problem 1 and problem 2, we were given moments to find the reinforcement, which is the area of the steel bar. But in this question now, we are given the area of the steel bar to calculate the moment that leads to the provision of this area of reinforcement. Now, if this is taken, all we need to do, like I said before, is that anytime you are dealing with word problems, the first thing you do is to extract the parameters from the questions, which include the known and the unknown parameters. And this actually helps you to know the formula to use or the relationship between the known and the unknown parameters. And if this is taken, then let's continue. So we put down our solution and we said, given that here the ultimate moment of resistance is unknown. Now the width of the section is given as 225 in millimeters. The depth of the section is given as 450 millimeters. Then the strength of concrete is given as 30 Newton millimeters. The strength of steel is given as 460 Newton millimeters. Then finally, what else are we given? We are given the area of reinforcement. So the area of reinforcement, AX, is equal to 4 y 25. This is the reinforcement that we have, and this is equivalent to the area of this steel. So like I said earlier, AS is given, but moment is unknown. Now, how do I get to calculate the ultimate moment of resistance? Having been given the area. Now, to be able to ascertain the actual area of this steel, there are 2 ways to do it. It is either you calculate for the area of this section manually, or you make use of the design table. But I will recommend that you make use of the design table. But for you not to be short-circuited or to be limited to one approach, I will quickly share the 2 ideas here. Now, first is that you know that this is a diameter. And anytime you have a diameter you want to calculate for area, you actually make use of the area of a cycle. And the area of a circle is pi d squared over 4. And now here, the number of bar here is 4. So I multiply by 4. Then this would have given us pi over 4 multiplied by the diameter here is 25 all squared, then multiplied by the number of bars. When I solve this out, this would have given us 625 per millimeter squared. Then you can multiply with the actual value of pi. Now, whatever you have here is the actual value of the area of steel, which is based on calculation. But based on the standard code of practice, BS 8110, according to criteria, we will make use of our table. So all you need to do is to go to the table, and now we are designing beams. So you look for the table for beam, for the area of beams. And now I have the area of beam here in table 3, according to the list I have here, or the table format that we have. Now on this table, I have 4y25, so I will trace 4 under the number of bars, then trace also bar size 25, and I will check the point of intersection of these two numbers. And the point of intersection, the area we have there is 1960. Are you there? Now, so I will put down the value of this 1960. Prior to this question, in question number 2, we understand that when we have an area where we have 1901, all we did was to go to this table and provide an area that was actually 4y25. Now, we are now given 4y25. All we need to do is to go to this table and trace out 4y25. And when we trace out 4y25, the equivalent area of the reinforced member is 1960 millimeters squared. Now at this point, we need to understand that from stress block at equilibrium, the force, the compressive force in the concrete is equal to what? The tensile force in the steel. At equilibrium, the compressive force in the concrete is equal to the tensile force on the steel. That is to say, F of CC is equal to what? F of CSC. This is the what? The compression force of the concrete. Why this is the tension force of the steel? Because the concrete is at the compression zone, while the steel is at the tension zone. And we know that the sum of upward forces is equal to sum of downward forces. Likewise, the sum of what? Forward forces is equal to sum of backward forces. Are we there? So, if this is taken, all we need to do, what is the compressive force of concrete? Now, the compressive force of concrete is 45% of the strength of steel, F of Cu, multiplied by the section of concrete at the compression zone. Then multiplied by 95% of the steel strength, multiplied by area of the steel. This is what we have. This is the area of the concrete at the compression zone. This is the area of the steel at the tension zone. Now from here, all I need to do is to find the depth of the concrete at the compression zone. And how do I have this done? I will just simply make S the subject of formula, and therefore we have X is equal to 0.95 FyAx all over 0.45 F of Cu multiplied by B. Now we will impute the values of these parameters. Then we have X equal to 0.95 multiplied by 460 as given. Then multiplied by the area provided 1960 all over 0.45 multiplied by the strength of concrete multiplied by the width of concrete 225 all as given. Now when you multiply the numerator and equally multiply at the denominator, then divide the numerator by the denominator, the outcome would have given us 8282 millimeters. This is the depth of the concrete at the compression zone. Now that we have successfully obtained this, there is a limit to the depth of concrete at the compression zone, which we are quickly going to calculate. Now we know that the depth of concrete at the compression zone is 90% of the neutral axis, and this is same thing as 0.9 x. Now we will quickly evaluate the depth of the neutral axis x. And now if we make x the solid of formula, we will have this as x all over 0.9. And then we have this as s calculated. Then the value of this guy is 282. Then we put down 282 in millimeters, all divided by 0.9. And this will have given us 313.3 millimeters. Now we have successfully obtained the neutral depth of concrete based on the dimension of the beam section that we are given. Now the next we do is to check this with the limit or the maximum possible. And we said earlier that the maximum possible limit is equal to 0.633 multiplied by effective depth of the concrete. Now we know the effective depth to be 450. Then we have this as 0.636 multiplied by 450 millimeters. And when we multiply this guy by this guy, all we simply have is 286 millimeters. Now we find out that the calculated value based on the dimension of the concrete beam section given is more than the limit possible. This is the highest that we'll have. But now what we have is more than this. It therefore shows that the beam section will fail by brittle. So anytime the calculated limit depth is more than the limit, anytime the calculated is more than the limit, such concrete beams fail by brittle. And anytime we have this, the ultimate moment of resistance as required is given as ultimate moment of resistance R, MR, is given as 0.95 Fy AX multiplied by Z. This is how we calculate the ultimate moment of resistance that a steel can resist. Now, if this is possible, now from this equation, we already have the value of the strength of steel, we have the area of the steel, but we have not obtained the lever arm. And we said earlier on that the lever arm is depending on the lever arm factor. And for this case, the lever arm is given as Z is equal to D minus X over 2. And by extension, the value of this guy is 450 minus X is 282 all over 2. Now, when we divide this guy by 2 and remove the outcome from 450, we will have this as 309 millimeters approximate value. Now, this is the result. Now that we have successfully obtained the lever arm of this beam, all we just need to do is to substitute into this equation. And when we have this done, we are good to go. Now we come in and therefore we substitute MR is equal to 0.95 multiplied by 460 multiplied by area of steel 1960, then multiplied by Z, which is 309, and this is measured in Newton millimeters. Now, when we have this multiplied, the outcome will have given us 265 multiplied by 10 raised to the power of 6 Newton millimeters. And as usual, we normally leave our moment in kilonewton meters, and to convert this guy to kilonewton meter, we simply replace 10 raised to the power 6 Newton millimeters by 1 kilonewton meter. And then this will have given us 265 kilonewton meters. So this is all about this question. It is very, very simple, like I said earlier. All you need to do when it comes to the design of beam is to know the criteria that are being provided by the codes of practice, BS 8110. If this is understood, then we have nothing to fear. Now, like I do always tell you guys, when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. So it is very, very important that you know the principles that work in structures. Like I said before, all structural problems classified other beings are solved the same way, except you are dealing with another structural element. So now we have looked at how to determine the area of reinforcement for a simply supported beam. In our next lesson, we will be examining that of a cantilever, that of a fixed-ended beam, that of a prompt cantilever, that of overhanging beams, and that of fixed-ended and continuous beam. So if this is taken, and if you have any question, don't hesitate to ask your question. So at this point, if you have not subscribed to this channel, do consider subscribing to this channel if you find this content helpful. And ensure you turn on the post notification bell for more exciting videos if you really want to miss out for the next line in class. Finally, don't forget to share this video, like this video, and make your message. Love you. Thank you for watching. See you guys in